Ever wondered how the buildings around us get built? And maybe more importantly, how they should be built to be, well, genuinely sustainable. Welcome to the deep dive. Today, we're really digging into a topic that's crucial. It literally shapes our cities, our future, energy efficiency in buildings, our mission, to unpack a really foundational, actually mandatory requirement within the LED green building system. Specifically, we're looking at LED BD plus CV5's energy and atmosphere prerequisite EAP2. That's minimum energy efficiency. That's bad. Sounds a bit technical, I know. Maybe a bit of a mouthful, but it's absolutely critical for, shaping our future built environment. And before we really plunge into all the fascinating details of, well, building for a better future, if you're as curious as we are about the world around us and you want more insights like these delivered straight to you, make sure to subscribe, to hear more about this world.
Yeah, and this dive into EAP2 is so important because, when you look at the big picture globally, buildings aren't just, well, structures. They're massive energy consumers. Huge. They account for a really substantial share of global energy use. And, as a direct result, a significant chunk of greenhouse gas emissions.
Wow, yeah.
So that's why EAP2 isn't just some technical detail you find on a blueprint somewhere. It's really a foundational step. It's about tackling some of our biggest environmental challenges, like head-on. It sets a baseline that's just non-negotiable.
That global impact, yeah, that's definitely a compelling why. So, okay, let's talk about the actual intent of EAP2. What is this prerequisite truly trying to achieve? What's the big goal behind setting this minimum standard?
Well, the goals are actually pretty straightforward, but they have a huge impact. First off, EAP2 aims to significantly cut down the environmental harm that comes from just using too much energy in buildings. Think about it, the emissions from power plants making electricity for our buildings, the strain on resources.
Right.
EAP2 tackles that directly by just requiring less energy from the start. Secondly, it sets up a clear, measurable baseline, a floor, really.
Okay.
This means that every single building going for LED certification, doesn't matter what other cool green features it has, it must meet this fundamental level of energy efficiency. It makes sure sustainable isn't just a fancy label.
So it's verified performance.
Exactly. Verified reality right from the ground up. And finally, by doing all that, it promotes responsible energy practices. And that is a kind of dual benefit. It minimizes those building-related greenhouse gas emissions, sure, but it also significantly cuts operational costs over the building's whole life.
Okay.
So it's a win for the planet and, a win for the owner's wallet, too.
Got it. Establishing that baseline seems like the absolute key starting point. But okay, let's get practical. How do the teams, architects, engineers, builders, how do they actually meet this standard on a project? What does compliance really need from them, on the ground?
Right. So to meet EAP2, project teams basically have two main ways, two pathways to show they comply.
Yeah.
Each has its own method, its own implications.
Okay, two paths.
Option one is what we generally call energy modeling, sometimes known as performance-based compliance.
Energy modeling, okay.
This path involves creating a really detailed, pretty sophisticated computer simulation. Think of it like a virtual building. And this simulation predicts how the building is actually going to use energy.
Like a forecast.
Sort of, yeah.
Yeah.
And this model is usually based on recognized standards like HHRE 90.1. That's a really common one.
HHRE?
Oh, sorry. Yeah, HHRE is the American Society of Heating, Refrigerating, and Air Conditioning Engineers.
Right.
And their 90.1 standard is like the go-to consensus standard for building energy efficiency in North America and influential elsewhere, too. Now, the crucial part here is that the proposed design the building they want to build, as shown in the model, it has to outperform a similar baseline building.
Outperform.
By a specific minimum percentage. That percentage is often set by local codes, or AHRAE itself, and the model has to be really comprehensive. It needs to include all the significant energy users. So, your HVAC, that's heating, ventilation, air conditioning, all your lights and controls, the hot water systems, and, critically, the building envelope performance.
Okay, the building envelope. You mentioned that. Let's unpack that just a bit more. What exactly is covered there?
Good question. The envelope is basically the building skin, everything that separates the inside from the outside. So your walls, your windows, the roof, the foundation, and all the insulation packed into them.
Like it's code, essentially.
Exactly, like a winter coat for the whole building. It's vital for stopping unwanted heat getting in during summer or escaping in winter. Keeps the inside comfy with less energy.
Makes sense.
And getting back to the modeling, it also has to include major equipment and process loads if they're relevant. Think like specialized machines in a factory or maybe big commercial kitchen equipment. What's interesting about this modeling option is it usually gives teams more design flexibility. They can get creative, try different materials, different systems. As long as the final model proves they beat the baseline, they're good.
So innovation is possible.
Definitely. Plus, it often gives a clearer, sort of more detailed picture of the actual operational savings you can expect later on. Owners like that. Now, option 2 is the prescriptive path. This one also usually follows HHRA 90.1 or a similar local code.
Okay, so less modeling.
Right. It's a more rigid approach.
Yeah.
Instead of simulating the overall performance, it demands strict adherence to specific predefined rules or guidelines. This means every single component and assembly installation R values in the walls, the U factor of the windows, the efficiency rating of the furnace or AC unit, all of it has to meet or exceed a specific list of minimum requirements. It's less about proving the whole building works together efficiently through a simulation, and more about ticking boxes, proving each piece meets the standard.
Like following a recipe.
Pretty much, yeah.
Yeah.
It offers less design freedom because you have to use components that meet those specific criteria. But for maybe simpler, more standard types of buildings, it can sometimes be a more straightforward way to verify compliance. Maybe save a bit on the upfront design and modeling effort.
So the modeling gives you that flexibility, maybe a better long-term insight, while the prescriptive path is more, well, by the book, potentially simpler upfront. Is there a general rule or maybe a key reason why a team might choose one over the other? How does that choice really shape the project?
That's a really good question. And yeah, it's a strategic decision, not just a technical checkbox. Performance modeling, while it gives you that great design freedom and often uncovers deeper, more specific savings tailored to that unique building, well, it does demand more expertise up front. You need skilled people, sophisticated software. It's an investment.
Right, it takes more effort initially.
Exactly. So for complex projects, maybe really innovative designs or larger buildings where really squeezing out maximum energy performance is a top goal, modeling is often the better way to go. The prescriptive path, though, being less flexible, can be faster and more straightforward for simpler, maybe more conventional builds. Maybe where radical innovation isn't the main driver, or if the upfront design budget is tighter.
Right.
So it's really about balancing how ambitious the design is against the project's complexity and those initial cost factors.
I see.
The key thing is, it's not just technical, it's strategic, balancing aspirations with reality,
That distinction is really helpful. Okay, so regardless of which path they pick, modeling or prescriptive, what specific systems within the building are we talking about? Where do builders really need to focus to make sure they're hitting these minimum efficiency marks?
Yeah, let's dive into the specifics. What systems actually fall under this?
It's pretty comprehensive because energy use touches almost everything in a building. At a minimum, projects need to meet standards in several key areas. First, as we just talked about, the building envelope.
Walls, windows, roof, insulation.
Exactly, all those components. They form that critical thermal barrier. Then you've got HVAC systems. Heating, cooling, ventilation, these are almost always the biggest energy users. So their efficiency is just paramount, absolutely critical.
Makes sense. Biggest user, biggest target for savings.
Right. Then there's domestic hot water systems. Your water heaters, boilers, even the pipes distributing the hot water. They're looked at closely too. We also focus hard on lighting systems and controls. That covers everything from the type of light bulbs, high-efficiency LEDs are huge now, to the controls like dimmers, occupancy sensors, daylight sensors that make sure lights are only on when and where they're actually needed.
Smart lighting, basically.
Essentially, yes. And finally, where it applies, plug load equipment.
Plug loads, what's that? That's the energy used by anything you plug into an outlet. Computers, printers, coffee makers, kitchen appliances, TVs, vending machines.
Ah, okay. All the stuff we bring in.
Kind of, yeah. It's more situational, depends on the building type, but these loads are getting more attention because they can really add up, especially in office buildings or similar spaces.
Okay, so envelope, HVAC, hot water, lighting, and sometimes plug loads. That covers a lot. So once the systems are designed, the right parts are picked out, and they've chosen their path modeling or prescriptive, how do the teams actually prove it? How do they document and verify they've met EAP2? What's the evidence they need to show?
Right, proof is key. Documentation and verification are absolutely critical steps.
Yeah.
For option 1, the energy modeling path, teams have to submit the detailed results from their simulation, those reports. These basically show exactly how their proposed design performed better than that baseline building we talked about.
Okay, the model output.
Yep. And for both options, they need to provide detailed equipment specifications. That means things like manufacturer data sheets, product info confirming the efficiency ratings of all the installed equipment, the furnace, the AC, the lights, the water heater.
Proof the parts meet the standard.
Exactly. Proof they meet or beat the requirements. But beyond all the paperwork, there's a really critical, practical step. It often surprises people how rigorous it is.
Yeah.
It's conducting commissioning and verification activities.
Commissioning. Okay, tell us more about that. What does that actually involve? What does commissioning mean here?
Think of commissioning like a rigorous quality check or maybe a full diagnostic tune-up for the building's energy systems
Before it opens.
before, during, and after installation, typically. It's a thorough process, usually done by an independent third party, a commissioning agent. Their job is to make sure that all these efficient systems, the HVAC, the lighting, the controls, the hot water, aren't just installed correctly according to the plans, but that they're actually operating exactly as intended, that they're delivering the energy savings they were designed for in the real world.
Oh, so it connects the design to reality.
Precisely. It validates the performance. It's the practical check that ensures the design truly works efficiently, not just on paper or in a model. This step often catches installation errors or control issues that, if missed, would lead to much higher energy bills and probably occupant complaints down the road.
That makes a ton of sense. Design it right, pick the right parts, install them correctly, and then prove it's all working together as planned. So, for anyone listening who's involved in building project, maybe a developer, architect, engineer, contractor, even an owner thinking about a new build, what are the best practices? How do you meet this minimum standard effectively and really set yourself up for success right from the beginning?
Yeah, great question. The earlier you bake this thinking into the project, the smoother it goes and the better the results.
Mm-hmm.
One of the absolute top recommendations is engage qualified energy modelers and engineers early, like really early in the design process.
Don't wait until the drawings are done.
Exactly. Get them in at the conceptual stage. They can spot the big opportunities for savings and also the potential pitfalls before things get locked in and become expensive to change.
Okay, early engagement. What else?
Second, really consider high-performance building envelope measures right from the start. Don't skimp here. We're talking about investing in things like advanced glazing triple-paned windows, low coatings, things that drastically cut heat transfer, and specifying much higher insulation levels in walls and roofs than maybe just the bare minimum code requires.
So focus on the buildings code first.
It's fundamental. These passive measures pay dividends for decades in reduced energy needs. Third, be smart about selecting energy-efficient HVAC systems and definitely implement advanced controls. Think beyond just basic thermostats. Smart thermostats that learn patterns, variable speed drives on motors so they only run as fast as needed, systems that respond intelligently to weather or occupancy.
More sophisticated controls.
Yes. Fourth, fully embrace efficient lighting. LED technology is fantastic for efficiency, but just swapping bulbs isn't enough. You need to pair it with intelligent controls, occupancy sensors, daylight harvesting, so lights aren't just burning energy when nobody's there or when the sun is pouring in.
Right, use light smartly.
And finally, and this is crucial for long-term success, pursue that commissioning process thoroughly and, ideally, continuous monitoring afterwards. Commissioning ensures everything starts off right, catching any installation or design flaws.
Mm-hmm.
Continuous monitoring, using building automation systems or sensors, helps track how the building is actually performing over time. It lets you make real-time adjustments, catch problems early, and ensure you maintain that high performance throughout the building's entire life.
So it's not just about getting it right on day one, but keeping it right.
Exactly. It locks in those savings long-term.
Okay, this all paints a really clear picture of the process and the best practices. So let's zoom out again. What does all this really mean for us? For the people who live and work in these buildings and for, our shared future. Beyond just getting that LEED plaque by the door, why does this specific prerequisite, EAP2, truly matter for you listening, for the buildings you use every day, and, well, for the planet?
Yeah, this is really the core of it, isn't it? Meeting EAP2 is absolutely essential, yes, but it's fundamentally not just about getting a certificate. It's about creating buildings that are genuinely sustainable, that are resilient to energy price shocks or climate impacts, and that are cost-effective to operate for their entire lifespan.
Sustainable, resilient, cost-effective.
Right. By setting this mandatory baseline for energy performance, every project that meets it is directly helping address climate change. It cuts those greenhouse gas emissions we talked about. It also drastically reduces long-term operating costs. For owners, for tenants, real money saved over decades, which frees up resources for other things.
Lower energy bills.
Absolutely. And there's another benefit, maybe less obvious, but just as important: occupant comfort and well-being. Buildings designed for high energy efficiency are often just nicer places to be.
How so?
They tend to have fewer drafts, more stable indoor temperatures year-round, often better indoor air quality because the ventilation is carefully managed,
Mhm.
more consistent and comfortable lighting. It all adds up to a healthier, more productive, just generally more pleasant indoor environment for the people inside.
That's a huge benefit.
It really is. It truly boils down to that mantra you hear sometimes in this field, the one from our sources. Start strong, build efficiently, shape a sustainable future. EP2 is that start strong part.
Hmm.
Ultimately, yeah, EP2 sets that crucial, non-negotiable baseline for energy performance. It's the fundamental first step, you could say.
Mm.
A critical floor that ensures every single EDD-certified building is making a positive contribution toward a genuinely sustainable built environment, minimizing its impact, maximizing its value right from day one.
That's a really powerful way to put it, minimizing impact from day one. And, it makes me wonder, thinking beyond just this prerequisite, if EAP2 sets this non-negotiable baseline, this floor for efficiency, what does that really mean for innovation? Does setting a floor somehow limit the ceiling? Or could it actually empower designers to push boundaries even further in other areas, knowing that this fundamental energy performance piece is already guaranteed? And thinking bigger picture, how might this transform the very look, the feel, the function of our cities over the next few decades if every new building had to meet this kind of fundamental standard? It's definitely something to think about. Well, this deep dive into energy efficiency, into EAP2, has just scratched the surface of how these essential standards are shaping our world around us. If you enjoyed understanding these details, maybe getting into the weeds a bit on how buildings become more sustainable, you want to keep discovering more, please join us again next time on the Deep Dive. The best way to do that, just hit that subscribe button. Thank you so much for joining us today. We'll see you next time.